A square root undoes squaring. So that's the same thing as having a power of 2. A cube root undoes cubing, or power of 3. Fourth root undoes fourth power, and so on and so forth. Here we're only going to be focusing on the square roots, and specifically the principal square root. So 2 squared is the same thing as 2 times 2, which of course is just 4. That means that the square root of 4, which is also going to be written as just like this without the 2 written there, because square roots are used so frequently. Now this is the same thing as saying 2, because 2 squared equals 4. That means the square root of 4 is 2. That's what the square root does. This is called the principal root of the square root of 4, positive 2. Now, because the negative 2 squared is negative 2 times negative 2, negative times negative is positive, 2 times 2 is 4. Because of this, then this is technically also true. However, whenever you're going to see just the square root of 4 like this, then you should always think of this as the positive version. This one will specifically be written as negative square root of 4, which will tell you that's going to be negative 2. This again is called the principal root, and this is just another root. A perfect square is a number that comes from an integer multiplying itself. So the square root of 1 is 1 times 1. Well, 1 times 1 is 1 squared, which means the square root of 1 is 1. We already talked about this one. This is going to be the principal root. For all of these, we're talking about the principal root. The square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3, because 3 times 3 is 9. The square root of 16 is 4. 4 times 4 is 16. The square root of what is 5? Well, 5 times 5 is 25, so the square root of 25. 6 times 6 is 36, so the square root of 36 is 6. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. So the square root of 81 is 9. And the square root of 100 is 10. 10 times 10 is 100. 11 times 11 is 121. And then the square root of 144 is 12. 12 times 12 is 144. So the number underneath the square root is always going to be the square of the number that results. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. Over here, we're asking general questions. What's the square root of 225? If you plug it into a calculator, you're going to see that this is 15. 15 times 15 is 225. The square root of what is 100? Well, just like here, right, we had 10 times 10 is 100. So all we need to do is 100 times 100. And that's going to be 10,000. The square root of 10,000 is 100. The square root of 529, if you plug it into a calculator, we get 23. 23 times 23 is 529. And finally, for this one here, this is going to be a large one. I'm just going to take 6481 and multiply it by itself. 6481 times 6481. And that gives me 42,003,361. If you chose a number at random, it would most likely not be a perfect square like I have written here. It could be a fraction of perfect squares, or most likely it's going to be some kind of random number that's going to be a decimal. So for instance, the square root of 103, this is not a perfect square. It's not going to be a nice number. It's just going to be a long decimal number. And to find that, we just have to plug it into a calculator. So the square root of 103 is, I'm just going to round this, so 10 point, well, I'll write like this, 889, and then it just continues on. There's no repetition in the decimal. Now this one, if I take a square root of this, we're going to end up seeing that this is going to be 4/3. Because the square root of 16 is on top and the square root of 9 is on bottom. This actually ends up being the same thing as taking the square root of the top times the square root of the bottom, or divided by the square root of the bottom. And that's going to end up being 4/3. If you plug it into a calculator, you're going to end up getting 1.3 repeating. And finally, the square root of 5. Once again, this is not going to be a simple number. It's going to end up being an infinitely long number. 6, 0, 6, 7, and it just keeps going on indefinitely. There's no repetition to it. Not like how this one repeated 3 indefinitely. This one will never repeat the same number, same pattern indefinitely, but it will continue on forever. We can compare these numbers on the number line and just plot them on there in different fashions. It says without a calculator, you can of course use a calculator to do this, but the idea is that the square root of 2, well, we know that the square root of 1 is 1, and the square root of 4 is 2, which means the square root of 2 has to be between these two numbers. Since the square root of 1 is here, the square root of 4 is here, the square root of 2 is going to end up being somewhere around here. Now, the square root of 11, same kind of thing. The square root of 9 is 3, and the square root of 16 is 4. So the square root of 11 is going to be between them. This is 3 and 4, so 3 and 4. The square root of 11 is probably going to be somewhere around here. If you wanted the exact, we just type into a calculator. The square root of 40 is between the square root of 36, which is 6, and the square root of 49, which is 7. So the square root of 40 is going to be between 6 and 7, and it's probably going to be somewhere on this end here. Somewhere around there. Okay, the square root of 60 is going to be square root of 49 is 7. The square root of 64 is 8. And it's closer to 8, so I'm going to say it's probably somewhere around here. And finally, the square root of 99, this is going to be just below the square root of 100, which is 10. So square root of 99 is probably going to be somewhere right around here. So of course, just use a calculator to find the exact number, but this is the idea that you can kind of think of them always being between different perfect squares, and that can kind of give you a quick estimation of where to put it at.